I'm CK. Tonight we're going to be doing another module from Frequency Central out of England. It's their More VCAs. It's a dual VCA module based on old ARP circuitry. And since, just like VCOs, you can never have too many VCAs, we'll see what it sounds like. Hope you enjoy the video. So here's the box, and as typical, it's got their support address. I got this from, purchased it from thonk.co.uk, where I get most of my eurorack modules. Let's see what's in the box. Again, paper bags holding the parts, which I appreciate a lot. It's not plastic to throw out, it's paper to be recycled. Frequency Central sticker, I have one of those on my sticker wall already, so I don't need another one. Eurorack power supply cable. Let's get the box ready for recycling. Now, let's see what's in the bags. This feels like the circuit board and front panel bag, so we'll look at that first. Two circuit boards, one front panel. So we've got initial CV in and out, initial CV in and out, and CV in. On the boards, typical, oh, this is a little, I was going to say typical great quality, and it is good quality, but there's a little bit of fiberglass fuzz on the edges. Hold on one second. I'll just take a little fine sandpaper and dress that up a little bit. It's an artifact from when they separated the boards, when they got them back from manufacturing. But I don't want to have little pieces of fiberglass sticking out. And this was an edge piece, so I don't have to dress that edge up. Designed by Rick Holt, PCB by Johnson Dunn. That's the same pair that did the System X envelope control I did a little while ago. Board, besides the little fiberglass fuzz, is fine. The typical for them through-hole plated circuit board. On the board itself, all the components are marked with their value, so you don't necessarily need a build guide to put this all together. We'll look at the build guide, of course, because we want to evaluate that also. And the PCB, same design, circuit design and PCB, but we learned something more. We learned that Johnson Dunn's middle name starts with an S. So we're almost to the point of figuring out what it is. I'm just kidding. Let's see what's in this bag. Some stuff. I think this is probably for the main logic board, because it's got our IC socket, our IC, various capacitors, resistors, and like I've noticed they've been doing lately, they're writing the resistor value on the little strip of paper that holds the resistors together, which is very considerate of them. Keeps you from having to figure out color codes or putting a meter on it or doing whatever. You can be mentally lazy and throw it together. So that's the one board, and I'm going to keep that PCB with it because I believe that's all the componentry that goes on there, except these two trimmers, which I don't see. So they must be in this bag. I wonder why they separated the bags like that. Got a couple that should have our jacks, some pin headers. Here are the trimmers I was looking for. 2 potentiometers, 100K each. The cheapo knobs Frequency Central uses. I would like nicer knobs, please. Go talk to the guys at Beast Tech. Say, where do you get your knobs? They're great. Power connector, and it's a keyed one, which is always increases safety of your rack. So that's it. Looks pretty straightforward, and as you can see, it's very narrow, 4 HP. So you get 2 VCAs on a 4 HP unit, which is pretty good, packing them in tight. So I'm going to get the soldering iron heated up and we'll start putting this thing together. So I took a look at the build guide, and again, very reminiscent of the System X build guide. It's pretty straightforward, pretty simple, but so is the circuitry, so I'm not too surprised at that. And just 2 pictures of, well, 3 pictures total of the boards, and the pictures are okay. They're not in progress, or there's no picture of the complete units connected together, but you can get that from this video if you want. First things first is resistor time, and I will do that, and it'll be fast playback for you, because resistor time is usually pretty uninteresting, nothing particularly stunning in the resistor application. And while I'm doing it, I'm going to be listening to WQXR out of New York City. It's 105.9 if you're in the metro area, but if you're like me out in California, they have an iPad app and apps for other platforms. WQXR is, in my opinion, the best classical music station in the world, and I've been listening to them since I was a wee lad, and I like listening to them while I build stuff. And tonight we're going to start listening to Francis Joseph Gossick's Sabinus. Enjoy watching speeded up resistor time. So resistor time went pretty quickly, as you saw, and I also put the 4 resistors on the pot and switchboard just because I was in the zone on resistors. Next step is to put the IC socket in, and to keep it in place while we get it started soldering, use a cushioned set of locking tweezers. Do one leg. Now take the tweezers away. Look at the top. Adjust, push it firmly down, and make sure it's fully seated by heating that little dab of solder again. And then you're flat and flush on the board. That's the socket. Now we do the transistors, your PNP transistors, which is why he marks the board with P's instead of NPN transistors, which he marks with N's instead of putting the actual part number on there. I don't know how I feel about that, because that's almost an implication that any old PNP transistor would work in this, which is probably not true. Put the transistors in, bend the middle leg, set it down and bounce it around a little bit. And as someone once recommended to me, you always solder the middle leg on a transistor first, because then you're less likely to bridge. I don't know whether that's true or not. But I do it anyway, just because why not? Because I have no reason to do it a different way. Now we do the power connector, and this outline shows where the notch goes. And if you want to be double sure, which you always should be because it doesn't cost anything to be double sure, look at the actual power cable, and there's the tab that goes in that notch, and the red stripe is pointing to the stripe on the PCB, so we know it is correct. Now again, we hold it, power connector on the back of the on with my pinky finger on the back, solder one leg. Now we eyeball it, heat that leg up again, and push it. Let the solder cool again, and it's perpendicular and flat on the board. Don't ever hesitate to put a little extra solder on those pins, because that solder is the mechanical connection, mechanical glue that's keeping this connector stable through potentially many times of running the power cable in there and out. Now we're going to do the electrolytics. They are 10 microfarad, 10 microfarad, 10 microfarad, 10 microfarads. So, and then two 4.7s. So let's pull the 4.7s out and do those first. Long leg to positive. Next step is the two 100K trimmers, or 10K, yeah, no, they're 100Ks. Now I'm gonna preset these. The author of the kit suggests that the midway point is probably good. He tells you how to bias them, but I'm just gonna leave them midway probably. Now we're gonna put the male pin headers on, and they are gonna be 1, 2, 3, 4, 5, 6, 7. And as you'll notice, they're going, I'll call it downwards, for lack of a better term. They're going on the reverse side of the circuit board. All the pins down, none bridged. And while I'm here, I'm going to go ahead and put the IC in. Notch in the right direction, notch on the socket matches notch on the PCB. Pins look lined up. Push it together. No pins bent, all pins seated. So that's the logic board. Pretty simple. Now let's go do the POTS board. The first thing we're going to do on the POTS board is straighten the pins out on the pots, for criminy. So in this case, the author recommends soldering the pots down before we put anything else on, which is unusual. Most guides will tell you to seat everything on there, then put the panel on so everything's aligned. In fact, this same author has said that in previous builds, but what I'm going to do before I do anything else here is I'm going to put, I'm going to go out of order from him. I'm going to put the female pin headers on the board first before I put sockets and other things on, just because I've got lots of room to do it right now. I don't have other components interfering. I'll leave the pots on because I already set them in there. But just my personal preference, I want to have lots of room here. Check to make sure we're still going to be fine on positioning. Yep. So we'll solder the rest of that. I should have flipped this board over so I can use my soldering aid over. And as he reminds us, don't forget to solder the support legs too, because again, anything that a human interacts with on any electronic device, don't hesitate to use a good bit of solder to make sure that the component doesn't ever come loose or get an intermittent contact because it's wiggling or whatever. There's a lot of ills can come from components being a little bit loose. Now I'm going to put all the sockets on the board. They're simple, and I'm also going to take all the panel screws off them. He goes on to say use resistor leads to ground them. However, the sockets that they're supplying have a ground pin in them, so you don't have to do that. So I'm going to go ahead and take all the panel nuts off and solder these things on. Again, in fast replay. Now just a quick comment before I go back to fast motion. The sockets are mounted on the board. I've already done the pin headers. See, this is was part of my thinking. So what I'm going to do now is I'm going to put the front panel on, make sure all the jacks get lined up appropriately. And there, all the jacks are lined up appropriately. I'm going to spin the panel nuts down on the potentiometers because since I've already put the pin headers on, I'm not going to take this back apart. I'm going to solder the jacks on while they're in perfect alignment because the panel's in place, and then I don't have to take the panel back off to do the pin headers, which would be a typical approach. So that's why I did what I did earlier. Back to fast motion as I solder these jacks. Now I'm going to do the hardest part for me, which is putting the potentiometer knobs on and having the index line point to something halfway useful and match the index line on the other pot. Both tasks are very, very difficult for me. I want these up just a hair so they don't rub against the back, the top of the case for the potentiometer. And you don't want to tighten these set screws too much. These hybrids that have a plastic body and a brass set screw, don't crank it down because you'll just strip the plastic and you won't be happy at all. Now we're going to mate the two assemblies, and to do that we're going to actually say to ourselves, I wonder which way is up. And we'll look at the build guide pictures just to make sure. Even though the build guide does not show a picture of the boards joined, that's what I said before. However, even though it doesn't explicitly say this, the power connector is down here at the bottom, as is typical. The printing on the circuit boards shows, they're both this way readable. So this is the way they go together. However, it would be nice and beneficial to people who may not have done, oops, I missed a pen, who may not have done a lot of these, or even a beginner, because this is a pretty straightforward kit. It'd be nice to give people a picture so they can see how these go together. So that's it, a very quick build and relatively uncomplicated circuitry. That's the way it looks from the front, the side, the back, the other side, the top, and the bottom. We'll plug the power cable in, put it in the rack, and let's see how this thing works. Alright, we've got it in the rack, and I assume it's on because it hasn't caught fire, but as you may have noticed, there's no LEDs on this device. So we've got a Buffaco MIDI thing feeding the System X envelope from Frequency Central. The envelope will be fed into the More VCA's VCA and out to the pile amp with a signal tone coming from a ADAC Systems VCO. I also have a Danny Sound VCA here that we may want to try if we want to do a comparison or something. I have another idea about something over here, but we'll get into that, and I don't know if I'm going to do it or not. And I've got the Division 6 sequencer standing by, though I don't think I'll be doing that. Anyway, let's set the initial CV low and set up a moderate envelope. Adjust my MIDI keyboard down a little bit, and let's hear what she sounds like. Let's move the initial CV up a little bit, and as you can hear, you can have it almost self-trigger at that point. If you turn it up this far, it's basically open all the time. If you want to do drone stuff, so it's easy to, instead of trying to hold down a MIDI note or whatever, you can just crank up the initial CV and it'll give you a good drone. Just for fun, let's hear what that same thing sounds like through the Danny Sound VCA. Maybe a little smoother, or what you might call fatter, since of course the folks who make the Danny Sound thing were trying to go for a more Moog rounded sound. where this is more ARPy. Now, one thing the website does say is that if you drive the input volume of the signal, the audio signal, they say that it can break down or create some interesting overtones. So what I'm going to do is pause the cameras for a second. What I'm going to do now is I'm going to drive it with the Division 6 mini sequencer I have in the rack. And one thing, as I've been messing with this, I've realized I want to have the initial CV just barely, I mean just a little bit beyond transparent bleed through. So as you can hear right now it's silent, but if I take it up a little, you can start hearing the frequency go through all the way to full up. So I'm going to take it just to a little bit below a little bit of bleed. That's what feels good to me. You'll want to adjust, and again, I haven't done the biases, so that's we're dead in the middle on those, so that may have some influence. So let's do a simple sequence. Now I'm going to speed it up and see how snappy, I know the envelope's really snappy. We'll see how the VCA is. First I'm going to give a little more. Now we'll start speeding it up. So it gives me what I want, which is discrete notes for each, so it's fast enough even at the fastest speed of this sequencer to keep up, and that's real good. So it's a nice little unit, obviously takes very little space in your rack, pairs nicely with the frequency central envelope, and a very quick and simple build. So it's a good little unit. Hope you enjoyed the video.